tonight we have Kirk Hardy from the Tahoe Institute of Natural Science. Sciences? Science. Okay, thank you. For natural science. And Kirk studied at UNR and is also an adjunct professor here at Sierra Nevada College, and will be talking to us about winter birds. So I'll turn it over to you.
All right.
Thanks. Give him a warm round here.
Well, thanks everyone for coming out tonight. I'm hoping my voice makes it through, as my wife and son got sick on Sunday, and now today is my turn. Anyways, I'm one of the co-founders and co-executive directors of the Tahoe Institute for Natural Science, and we're talking about winter birds of the region tonight. But first, before we get into that, just a little bit of background on the organization I work for. We really have three main outreach areas, or three main areas that we work with. The main one being our research, which we do a lot of wildlife research in the basin, birds, insects. We've done some tiger beetle studies. We're also doing some snowshoe hare and white-tailed jackrabbit studies right now. So we do a lot of research, and that stuff helps to inform our outreach and our education, which I'll get into those a little bit more. But we have a long-term goal of running a world-class nature interpretive center to Lake Tahoe. And this would be to talk about the wildlife, more of that connection, the terrestrial connection, because there's a lot of great organizations already doing water stuff like UC Davis Turk. But for education, we have K through 5 in-school science programs that are hands-on, teaching kids about bugs, bats, and birds. We also have field trips to nature areas. We're doing field trip groups to see our bird banding research these days now. And we also do summer camps, getting kids out looking for bugs and exploring the basin. And outreach, obviously we do talks like tonight. But we also do nature walks. We have a Lake Tahoe Bird Festival and different things like that. And some of the walks we do are on wildflowers, birds. We have snowshoe treks, like we have a snowshoe trek coming up this Saturday in Page Meadows on winter wildlife survival. We also have one for families on the 23rd up at Tahoe Meadows on calling it Snow Detectives, learning how to track animals in winter. We have also done some stargazing and meteor shower moon, things like that. And we also do citizen science, which is a way to get the general public connected to research. So collecting data for scientific studies, and most of these studies are regional or national, so contributing to a large data set like the Christmas bird count that we do every year, Swainson's thrush, bald eagle count, things like that. But let's move into the talk. So in the Tahoe Basin, there's been over 300 species of birds confirmed in the basin. Now in any given year, it's probably more like 150, maybe 200, depending on how mild or harsh the winter is. But considering that there's just over 900 species in the United States, we've seen about a third of all the bird species in North America right here in Tahoe. We have about 63 or so that are year-round residents, and those guys will stick around the basin if it's a mild winter. Like last winter, we didn't have a lot of snow, not too cold. This winter is a bit different. So last winter, we might have things like American robins and things like that stayed around the basin, whereas this year, with more snow, colder temperatures, they may have taken off, gone down to maybe the Carson Valley or maybe the Central Valley of California. So the question is, how can our birds survive? If we take this mountain chickadee here that we have up here in Tahoe, it weighs the equivalent of 2 quarters. So this little tiny bird that survives up here in the winter, and we've had some pretty cold temperatures. Like I've heard the coldest I saw was -16. On most nights, these guys are just sitting out on the branch of a tree. Occasionally, they might huddle up with some other individuals for warmth, but they're exposed to the elements all night long. So how do they do it? Well, the main thing they do is with feathers. Feathers are nature's best and lightest insulator. It's the reason we have down jackets, down sleeping bags, down pillows. It's the best insulator that nature has created. And feathers are actually made of keratin like our fingernail, the protein. But the one difference is when feathers are growing in, they actually have blood that's flowing in to help support the growth of the feather, whereas our fingernails are always dead, so we don't have that blood flowing to them. But once the feather's fully grown, the blood supply is cut off, and so then feathers can fall out in that fashion and not bleed. But it would bleed if it was pulled out while they're growing the feather. So let's see. And also, feathers can be double the skeletal weight of a bird. In most birds, that's the case. And also, coming into winter, when birds molt, they can actually add up to 50% more feathers. So they can really add on a lot more feathers in there. And our small mountain chickadee there can have roughly 200 or 2,000 feathers on it. When we get to a bird like a tundra swan, they might have like 25,000 feathers. So a lot of feathers in these birds. So now we'll cover some types of feathers. Of course, imagine everybody's heard of flight feathers. And if we look out here, these feathers out here are called the primaries. This is what produces the thrust, the force to push the birds forward. And then over here, we have what's the secondaries. And that's what produces the lift for the bird. But if you look, you see that they're asymmetrical in shape. They have a smaller leading edge with a longer trailing edge, just like the wing of an airplane. So it functions the same way an airplane wing being made after bird feather. Another type of feather we have are contour feathers. And I couldn't find a good picture that represented this. So these are symmetrical. They have the same amount of feathering on both sides of the shaft. And these two feathers together are the outside of the bird. It's what we see, the colors, different things like that. It gives the bird its shape. If it has a crest, it will help to form the crest, things like that. But the main thing that helps to protect the bird from the elements is the structure of those feathers. So if we look here, we have the shaft of the feather, and coming off of that is what are called barbs. Off of the barbs are a smaller piece called barbules, and a smaller piece off that are called hooklets. And I thought this was a good picture of the whole feather, but this was a good example of that. And the way these all work is like Velcro. So I imagine you've all heard of birds preening. So if I take this flight feather of a Canada goose, I can rough it all up. When birds take their bills and rub them across the feathers, what they're doing is zipping those feathers back together to make a nice, smooth surface. And so with that, you have a smooth surface for flight, but also you've created a water-resistant surface as well. So that tight structure that gets down really tight in there makes it so the water is repelled from feathers. So water will actually sit on top of those feathers. I don't know what bird that's from, but it could be. And this being a contour feather there, as you can see, the symmetrical, the barbs are symmetrical on both sides of the feather there. And another type of feather that's important, very important for protecting birds from the elements are down feathers. And these guys, they're kind of wispy. And the more space, the more air that can be trapped in between these feathers provides more insulation for the birds. So on the outside we have those contour feathers, and then our down feathers, and then the skin. And those down feathers in between provide a greater or lesser barrier to the elements. If we go back to our contour feather, you can see down here, downy barbs down here. A lot of the contour feathers also have an aspect of downy feathers to them. So they're providing the water-resistant outer plumage of the bird, but also providing some insulation qualities on the inside of the bird. But another feather that can help that helps to shape the appearance of the bird, sometimes provides some color in different parts of the bird, are what called semi-plumes. And these actually sit between the contour feathers and the downy feathers. And so they have a little bit of an insulative property, but really it's those downy feathers that provide the warmth on the inside. There's a couple other types of feathers, but the bristles over here are more sensory. A lot of birds have these around their mouths, will help them to detect birds and insects and fly at night for different birds, things like that. Then we also have phyloplumes over here, which are also sensory, but also can be used in mating displays. But getting into those is a little bit of a different talk. Back to our birds here. This is our dark-eyed junco that we have up here in Tahoe. And juncos are the most numerous forest bird in all of North America. So our juncos will stick around for the winter year, or stick around Tahoe year-round. But this is what they would look like in summertime. They've got their feathers folded down nice and neat. But in the wintertime, if it's really cold, birds can puff up their feathers. And what's that doing is it's creating more space between the outer feathers and the skin so that those downy feathers in between can really start to warm up that air in between and create that nice warm barrier to form. So it's really like these guys can put on and take off a jacket just in how they're moving their feathers. And each feather that grows in, excluding the phyloplumes, has muscles around it. So birds can really control every single feather on their body just about. You notice another thing that this guy is doing over here is in this picture you can see his legs, the bottom of his feet there. But over here he's got them covered up, so he's sinking down so that he can pull his legs up into that nice downy layer that's on the inside to help protect him from the cold. And just to expand on that a little bit more, the American robin, you can see he's got one leg sticking out there. So, other birds, a lot of are herons and things like that, ducks, gulls. You'll see a lot of times standing on one leg. Well, they're doing the same thing. They're pulling that leg up, keeping it close to the body, and within the feathers so that it's keeping the leg warm. And then when another leg gets too cold, it'll drop the other leg down. So they can go back and forth with that. All right. So, we've covered a little bit of how they survive the winter. Now, how do they get here? There's three main strategies, or ways, I would say, that birds end up here. One being migrants, birds that regularly come to the area we expect them every year. Get into eruptive in a little bit, and then also vagrants and strays. So, when we think about migration, most people think of it as a seasonal migration that birds from the north travel to the tropics and then back again. And migration is actually a lot more complex than that. There's altitudinal migration, there's east-west migration. If you get into the ocean, there's birds that are migrating the whole year round. So there's that, but in general for birds, what we're going to say is that movement from wintering grounds to breeding grounds and back. So, and it's something that's seasonal, predictable, and happens every year. We know that generally this time of year they're going to show up, they'll stay for a period of time, and they'll take off. And with migration, it's usually along specific routes. So we know that if there's birds nesting that are wintering down in Mexico and they end up in Alaska, they may choose to migrate west of the Rockies or east of the Rockies. There's different pathways that it takes. So even during migration, birds that you don't expect to have breeding in your area, you can still go and find them in certain spots. And the main reason that birds do this is reproduction. Ultimately, the benefits outweigh the costs. The birds that are migrating to nest have a greater chance of success than the birds that aren't. And it's just different strategies, but the birds leaving from the tropics coming to here have more resources available to them. So if you imagine going out to our Tahoe meadows in the summertime, it's nice and green, the wildflowers are out, and of course the mosquitoes are trying to eat us alive. The birds are all coming here to take advantage of that. So, but then the birds that also come here in the winter might be traveling all the way to the tundra and the boreal forest, where there's even more insects that are coming out in the summer. There's also longer day length. Here in the summertime, I think we get up to like 14 and a half, maybe 15 hours of sunlight. These guys traveling up further north have 20 to 24 hours of sunlight that they can use to forage to feed their young. So ultimately, the cold is what pushes birds away from areas in winter, but it's really the food sources that are becoming less that push them down to further areas to the south. So in our first bird that migrates to the area is our cedar waxwing. And I'm just going to show you guys this map over here. So the orange area up here is where we can find them in the summertime. The green area in the middle is where we can find them year-round. And the blue area is where they go to spend the winter. So you can see Tahoe right there is in the blue area. But our cedar waxwings are named for the waxy secretion that they have on their secondaries right here. Now, ornithologists don't know why they have that secretion, why it comes out that waxy, but it's believed it's something to do with mating and displaying the mates. But they haven't been able to connect it to anything yet. But these guys come down, and they're primarily fruit eaters. In North America, we don't have a whole lot of birds that are specific to fruiting. In the tropics, there's a lot of birds, but up here, not so much. So they're unique in that sense, and they're also unique in that they'll swallow seeds whole. A lot of birds will regurgitate seeds back out, but cedar waxwings will pass them through, so ornithologists have actually been able to determine how long it takes for them to digest foods based on how long it takes for them to pass seeds. And these guys, as it moves into fall, and fruit might have been out on the branches for a long time, if fruit becomes overripe and starts to ferment, these guys can actually become intoxicated on the berries. And part of their mating ritual is a male will pick a berry and he'll pass it to the female. And the female might scurry down the branch a little bit, come back to him, pass the berry back. And we might do that back and forth a few times, and then eventually the female will eat it. So just a really unique dance that these guys do. But these guys come from the boreal forest, so it's called the taiga. And this map here shows this great expansive area across the world. It's actually the largest terrestrial biome in the world. The oceans obviously being bigger than that, but you can see that as you get to the farther north area of this, it's really a much more open forest than we have down here. So a bit different. And so if you're in the summertime, this nice open feeding area, probably a lot of good berries in there. But in the wintertime, it could look like this. The temperature range for this region is anywhere from -65 to 86 in the summer, with an average winter temperature of -4. So if you're thinking of looking for berries in -4-degree weather, probably not a good chance of it if you push further south. All right, our next group of birds, what we call eruptive. And these guys, it's a sudden large movement where they're moving into an area where they're not expected, and it's unpredictable. We don't know when it's going to happen, but we do know that they do this behavior. This is really triggered by food shortages. If you think about berries and seeds also, a lot of times it can be abundant, it's not a problem, but occasionally there'll be a shortage. And what that'll do is it'll push those birds further south looking for more food. Which brings them a close related Bohemian waxwing to the area. You can see here on the map, these guys are breeding in Alaska and northwestern Canada there. So they're a little bit further north than our cedar waxwings. They're also heavily eating fruit. And they winter just north of this area. But you see this dashed blue line there? That's the area where they're eruptive to. So we actually had these guys in the area 2 years ago. For about a month, they were down at Taylor Creek. There was 100 of them, a flock that hung around. It took me 3 times to get out there, and I finally found them. But there's actually been 5 recorded sightings of these guys since 1962. 2 of the sightings have just been one individual, but the 3 other sightings have been anywhere from 15 to 200 individuals. And they also have this waxy feather there, the waxy secondaries. And both the Bohemian waxwings and cedar waxwings, because their food resources are moving around so much, going from bush to bush, tree to tree, they actually don't hold territories. It's more efficient for them to look for food in a flock. So with that, they've lost their ability to sing songs. So they're one of the few examples of a songbird that does not sing. And for nesting, they'll actually nest in colonies next to rivers that have access to berry bushes and also insects. A good portion of the rest of their diet is met by insects. All right, we're moving on to the vagrants. This is usually an individual bird. It could be 2 or 3, but usually small numbers. And these are birds that are well outside their range. They're in places where we don't expect to see them. And as this picture shows here, it can cause quite a stir in the birding community. You can get lots of people out trying to track rare birds down from Asia or Europe or wherever they might have come from. But they're closely connected to strays. Again, this is an individual bird, maybe a couple, just outside their range. They're not too far from home, but not in the right place. And I thought this cartoon summed it up a bit. Well, that's just great. We're lost. But will Mr. Macho stop and ask for directions? So why do we get vagrants and strays? Well, some birds just are unfortunate and are born with the wrong DNA. If you think about a bird traveling 1,000 miles, 2,000 miles, and their navigational hardware is just off a degree or two, that could put them a few hundred miles to the east or west of where they're trying to land. Some birds may have just become lost. Maybe a cat or some predator has chased them off, and for whatever reason, they just weren't able to orient themselves after that. Another one is storms. If birds are migrating and they hit a storm can blow them hundreds and hundreds of miles off of the route that they were on. So you end up with a lot of birds in misplaced locations because of that. The last reason really is juveniles. A lot of vagrants happen to be juveniles. They're just young birds that haven't figured out the ropes yet, and they end up in the wrong place. So this is a vagrant that we currently have in Tahoe. They haven't been seen for the last 6 days, but the week before that, a number of people saw them. There's actually birders coming up from the Sacramento area multiple times looking for them. I've looked twice out of Tahoe City and not seen them. But these are long-tailed ducks, and they've been hanging out pretty far off in the water, so they're hard to see, but they can dive down to 200 feet under the water. So they can get pretty deep down, and they're hunting for fish. They're looking for maybe crustaceans of some sort, so probably in Tahoe they might be eating our crawdads up here, something like that. But the one on the left there, with the pink bill, has been speculated this is a juvenile male, because it's a long-tailed duck, and we don't see a long tail sticking out there. And then this would be a female here with the all-black bill. And here's another plumage showing an adult male with those nice long tails. Now, see here that these guys are nesting really up in the Arctic Circle. So over into Russia and then northern Canada, northern Alaska, and along the coast in there. And then they'll winter down to the north part of Oregon, along the east coast as well. So you can see that they're well out of their expected range showing up down here in Tahoe. But another thing about these guys is their plumage. Most ducks molt twice. So we see, think of our mallard duck with the nice green head. They're wearing that for probably all but 3 weeks of the year. And for 3 weeks, they're just plain. They look exactly like the females, except the yellow bill. So, but these guys are actually molting 3 to 4 times a year. It's a complex molt where it's like not a complete. Some individuals are doing it slightly different than other individuals, but essentially from March through December, they're molting. So there's a lot of different plumages, and like one of the things I came across was saying that when they're on their wintering grounds, they're in their breeding plumage, when they're on their breeding grounds, they're in their wintering plumage. So the bottom line is it's complex and not understood yet. Well, a number of our birds that regularly migrate to Tahoe in the winter are ducks. So I thought it was appropriate to also talk about what are some of the strategies ducks use in order to stay warm through the winter. Is these guys are swimming through water that's almost icy and almost frozen, or walking across icy lakes and things. So ducks and gulls actually have this. It's what's called a countercurrent heat exchange. So on the left, we have what's called warm weather, where the blood on the artery coming from the heart, it's oxygenated, has all kinds of nutrients, will just pass by this heat exchanger here. And there's what's called a sphincter muscle that can close to push blood over or not. In the wintertime, these guys can close that sphincter muscle, and it pushes the warm blood over here, where it connects with the cold blood coming up from the feet and the legs, so that they can move heat from the body over to that cold blood coming back up, so that when the blood leaves the body, it cools off, but when it's coming back in, it's warmed back up. So that's the simplified chart. Over here, this right here is the countercurrent heat exchange. So countercurrent being that the arteries going down, the veins going up. But it's got, let me back up. When arteries and veins leave the heart, they're usually at their largest, the largest diameter that they'll have. And as they get out to the extremities, they get narrower and narrower. In this countercurrent heat exchange, they actually stay the same size through here and out into the feet. But up here is where they get small. And where they're getting small, what they're doing is they're branching out and intertwining so that they can have the heat more efficiently move over to the veins, pushing the deoxygenated blood back up into the bird. And this is, did that all make sense? And so this blood moving back into the feet there, you can see that as the blood gets out towards the feet, it can be close to 0 to 5 degrees there. So the feet will usually just stay a bit above freezing. And the way they can do that is they've only got skin, tendons, and bones. All tissue that does not need much oxygen or nutrients. So they don't need to be supplying them with a lot of nutrients to keep them active. They usually just put enough warm blood in there to keep them above freezing. Whoops. So down here it's really cold. As it moves up, they start to warm up, and they can actually be close to body temperature when that blood is going back into the core of the bird. So it's been estimated that this system reduces heat loss in the feet and legs by 90%. So it's a really effective way for birds to retain that heat, not be losing it to the cold waters, which will sap heat very quickly. All right. Yes?
Does that work also for terrestrial birds as well as aquatic?
No, as far as I know, it only works for ducks and gulls. I was trying to find like loons and grebes, and I didn't come across anything that talked about them having the same system. All right, so jumping into some more winter migrants. This is one of my favorite ducks, the hooded merganser. You can see these guys are, ducks are separated out into two groups. We have the diving ducks and the dabbling ducks. And so this is a diving duck. They have narrow bills that have serrated edges that allows them to easily capture fish. The fish are easy for fish to get out of the bills, but the serrations on the bills help them out with that. But they also go after crawdads and things like that. But these guys only show up here in the wintertime. And they have what's called a nictitating membrane. It's another eyelid that comes down. It's like putting goggles on when they dive under the water. So it helps protect their eyes and helps them to focus while they're under the water, swimming around, looking for fish and crawdads and whatever else might be down there. If we look at their map here, you can see that they're breeding up British Columbia, up into Washington, the coast of Oregon, but just showing up here in the wintertime. But much broader range over in the East Coast. The cool thing about these guys is that they actually nest in trees. So you see their nestlings over here, and these guys are at the most 1 day old, because at 1 day they leave the nest. And you can see this guy making his dive out of the nest. I tried to find a YouTube video of this, and all I came across was wood ducks. So, but if you're interested in seeing this, it's pretty cool seeing their little tiny wings flap, and they can actually control themselves a little bit as they crash down on the ground. And another duck that we have up here, you can see these guys, the northern shovelers, are actually breeding all through the prairie potholes and up through a good portion of western Canada and into Alaska. And showing up this purple being where they can be in summer and winter, but we don't have them in the wintertime here. For whatever reason, they don't show up here. But our northern shoveler, and they get their name from the shape of their bill, which I'll have a better picture of this guy coming up in just a bit. Their bill is actually about 2.5 inches long. So it's a good length to their bill there. And their females can actually look pretty close to a mallard. So over here on the left being a mallard, female here, but you can see this, how much bigger the female's bill looks compared to a mallard. They both have orange in their bill, but the shoveler's got the black, or orange bill with the black spots in there. And then the mallard's got the orange outline with the black in the middle. And you can't see any color on the wing here, but she's actually got a a green speculum that can show up there, so sometimes you see some green colors in there. Just like this female mallard is showing there. And they both also have orange feet, so if you don't look closely, you could confuse them, but hopefully not. But we can see here the bill. You can see these little, those little lines there? Those little serrations there are help with their feeding strategy. These guys are what we call a dabbling duck. So if you ever driven by a pond and just seen ducks sticking up in the air, could be mallards or somebody like this. And what they're doing is they're eating the vegetation at the bottom of the pond. And so when they're doing that, they're actually getting a mouthful of water at the same time, and too much water. So these little serrations on the side of the bill, they have 110 of them going all the way around, allow that water to drip out of the mouth while they're just eating the vegetation. And this is a nice look at the way that the bill comes out to a bit of a spoon at the tip there. And I think it makes this guy look a little angry. This next one is actually a subspecies. We actually have white-crowned sparrows in Tahoe year-round, but we have two subspecies. One that's here nesting in the summer, and then we have Gamble's white-crowned sparrows that are showing up in the wintertime. So you can see right here in British Columbia up into the Yukon, in the southern part of Alaska, is where the Gamble's white-crowned sparrows are breeding. And then they're showing up down here in wintertime. So you can see that little orange strip of purple there being year-round for white-crowned sparrows. That's really because of the two subspecies. So our subspecies that's breeding here is actually pushing further south, maybe down into northern Mexico, Baja California, like that. There we go. So our Gamble's white-crowned sparrows, this area right here is called a lure, and they have a gray lure, or lacking the black, that our mountain white-crowned sparrows have. So the mountain white-crowned sparrows being the sparrow that's breeding up here in the summertime. And these guys have an orangish bill, whereas these guys have a pinkish bill. So and actually the way it works out is the end of August, beginning of September, the mountain white-crowned sparrows take off and head south. And about a week later, the Gamble's white-crowned sparrows show up. So it's almost year-round that we have them close. But hawks happen to be the reason why I wanted to call this birds of the region as opposed to just Tahoe. Just because I think hawks are very cool, and wanted to talk about rough-legged hawks. And the guy on the left is what we call a dark morph. And hawks, for some reason, there's a lot of different morphs, color phases. So you can have anywhere from very dark, like the guy on the left, to this being a more typical, but there's also variations within there. And it tends to be, a lot of hawk species have this pattern. So this being our typical with the white head and upper breast, the dark belly, and then getting down into more white feathers down here. But if we look at the range map on these guys are breeding up in the tundra and a bit of the boreal forests that we get up there. So they're pushing way north, up into the Arctic Circle for breeding. And then they're covering a good swath in the United States, just excluding the southeast really, in the wintertime. And I'm teaching a field ornithology course for Santa Ana College this year, in the spring. And Saturday we went down to the Carson Valley, and we found, let's say, 5 or 6 of the rough-legged hawks cruising around the valley down there. Another spot where we can see them is to the north at Sierra. Sierra Valley? Yeah. Up at Sierra Valley. But in flight, these guys, in addition to having that white head, upper breast, and dark belly band, they also have dark wrist patches. So the end of the bird's arm and finger is really coming out to there, the rest of it being feathers. So have that wrist patch there, it's dark. You can kind of see it in the darker birds, but it gets a little bit harder. But these guys even have a bit of white going through the wings as well. And I wanted to point out, they get their name rough-legged hawk by the feathers that go all the way down to their toes. There's only 3 North American raptors that have feathers going all the way to their toes. These guys, a Phrygianus hawk, which we'll talk about in a minute, and also golden eagles. Most likely being a strategy to help retain heat. And in flight, you get to see the upper tail. You see that the base of the tail there has a nice white patch to it. So easily distinguishable from a red-tailed hawk in that sense. But these guys are breeding up in the tundra. So this map over here shows where all the tundra is in the world. So a lot of it being up in the Arctic Circle. And imagine these guys are used to wide open expanses. So if you think they're coming from this, Tahoe with all of its trees is not the habitat you expect to find them in. We occasionally find them in the basin, but not so often. But they do show up like Carson's and Sierra Valleys just every winter as far as I know.
I've seen them in the Owens Valley too.
Yeah, I mean, these guys are used to hunting in open meadows, open areas, so anywhere that has voles, mouses, things like that will provide an opportunity for them. But, you know, if it looks like that in winter, it can cause quite a challenge in finding prey. Now, there are birds that do stick up there, like the snowy owls. They're big enough that they can punch through the snow and get down to the lemmings and things that are cruising around underneath the snow, but for whatever reason, the rough-legged hawks aren't able to do so. Just fortunate for us, because then we get to go look for it. But another wintertime hawk that we have are ferruginous hawks. And the name ferruginous comes from rust-like, or iron-like rust appearance. So the rust of iron appearance you can see in the legs there, and also shown up in the wings. So a very cool hawk in that it's got this nice white underneath with these good nice patches of red showing up. But again, you can see these feathers that are going all the way down to the toes of these guys. And this is the largest hawk in North America that we have. And you know, their feet make a nice red V. You can see them in flight, but sometimes they're very pale individuals. Again, getting into a morph there where they might not have the red rays. And these guys do, their mating ritual is similar to eagles in that the male will fly at the female and they'll lock talons and they'll do a spiral going down. So that's another great YouTube video. Might not be able to find it with ferruginous hawks, but if you definitely look up eagles in a spiral, you'll get a good video. Well, you can see the range map here showing up this south or the north part of Arizona. Stuff, purple being where they are year-round, then they're orange where they go for breeding, and then showing up in our area for the wintertime. And these guys are actually nesting out in the gosh shoots in the Great Basin. So picture the gosh shoots over here on the left, but then over here being the gosh shoot mountains. So they're making their way over to the Carson Valley, up to the Sierra Valley, and probably a lot of valleys all throughout the state through the wintertime. All right, well, we don't have too many eruptive visitors to the area. And this next one, the evening grosbeak, actually is a bird that we usually have year-round in Tahoe, but in the spring they can be eruptive to the area, and not every year. And these guys eat seeds. So I talked about with this waxwings, it's fruit that's driving this, whereas with these guys it's seeds that's driving it. So seed crops, for whatever reason not being present where they are, pushing further south. So you can see they spend the northern part of their range up in the lower parts of Canada, pushing down into a wide swath throughout the winter. So you can see these guys in a lot of places in the United States. But a cool thing one thing about their beaks, the name grosbeak actually comes from German gross being large or big, so big beaked bird. But with that, they are the only North American bird that is actually capable of crushing a cherry pit. So very strong bills that they have. And these guys frequently travel in flocks when they're eruptive. So if you have a feeder out of sunflower seeds or something like that, it can be a matter of minutes where your feeder will be cleared out and done. So they can cause your feeding habit to increase in price. All right, we'll move into some other birds. This is actually a bird that we saw in the Christmas bird count down in South Lake Tahoe this year. When you look at its range map here, you see that it covers a good portion of Nevada, but it doesn't really come into the Sierra where we are. So it's not a bird that we expect to see up here, but it did show up here. So this is more of what we call a stray, a bird that's just slightly out of its range, showing up here. But in sapsuckers, they do what's, well, sapsuckers are woodpeckers. And they're unique in that sapsuckers actually eat sap. So they'll go through it, and you guys might have seen this, they make what's called sap wells. So they'll set up a circuit. They'll go around, they'll try out trees. The best trees for producing sap is where they'll go and they'll make these nice rows. And so what they'll do is throughout the day, they'll go to those trees that they like, and they'll check the wells, they'll drill them out, they'll eat a little bit, and they'll just keep going around and eating from them. And I know like Taylor Creek has a pair of red-breasted sapsuckers down there that are nesting, and there's a lot of trees that have this, so you can actually see evidence of it. And I know some people have asked me, like, well, can't they girdle a peat tree and kill it? Well, most of the trees that are native to the area will actually be fine with sapsuckers because they all evolve in the same area. But a lot of our ornamental trees that people have brought in and planted in their yards, those are the ones that tend to be girdled by sapsuckers. But also, sapsuckers have a habit of hybridizing. So the red-breasted sapsucker I was talking about that we have here frequently hybridizes with red-naped sapsucker. And this little bit of red coming on the breast is showing us in this nice solid head there is really intermediate between the two. This happens a lot more up in Oregon than it does down here. It's still possible. And actually there's a yellow-bellied sapsucker on the East Coast. It looks similar to our red-naped sapsucker. This has a bit more yellow on the belly. And at one point they believed all three of those sapsuckers, the red-breasted, red-naped, and yellow-bellied, were one species. But they've now separated them out, but they still hybridize. So a lot of the species concepts would say that you have a distinct species, they don't interbreed, they don't mix, but birds don't tend to live by those rules. So a northern shrike, and these guys, again, coming down, they're breeding in the far north into our boreal forests and even out into the tundra in some spots. Pushing down in the winter, you can see that they're actually in our area in winter. So this is one of those birds that they're expected in the valleys, in the surrounding area, Sierra Valley, again, Carson Valley, and maybe the Washoe Valley. You can find them, there's not very many of them. But in Tahoe, they would be considered a stray that's very rare. They don't show up in the basin very much. But they're a type of songbird that has actually become predatory. So if you look at the bill here, it's got that hooked bill like hawks do. So it's for tearing flesh. And these guys, their Latin name, Lanius excubitor, means butcher watchman. So they don't have the talons that hawks do that allow them, they can catch their prey, but they can't really tear into them. So what they do is they might find a barbed wire fence or a thorn bush, and then they'll impale their prey on it. You can see this guy is eating a bird there. So that's the way these guys are able to get out there. But the butcher bird is also what they're frequently known as. And we also have another species of shrike here called the loggerhead shrike, which is much more common. Again, the same thing where you can find it in the valleys surrounding Tahoe, but not in the Tahoe Basin. Looks almost identical to the loggerhead shrike, but it doesn't have as much of a curved bill, and it's got more of a dark mask. Here's another bird that I would call a stray to the basin, but expected outside the basin. Our tundra swans, and this is a picture that was taken by Dr. Will Richardson in November, flying over Mount Tallac. So great scenery there. Here's a little better picture of one. You can see the little yellow on the bill, the upper part of the bill there. Lets us know it's a tundra swan, but true to their name, we can see that tundra swans are nesting out in the tundra. So making a good distance flight, and you can find them down in the Sacramento Valley and also the valleys around here throughout the winter. Now, something I found interesting with these guys is During the breeding season, these guys are up on the nest, so they're sleeping on land at night. But in winter, these guys are actually sleeping out on the water. So taking advantage of that countercurrent heat exchange to make it through the nights here. And it's probably, I imagine that's probably a predatory thing. Sleeping out on the lakes keeps them away from predators like coyotes and things. Now this horned grebe looks great when it's in its breeding plumage, but a bit dull, kind of gray with white in the winter. So this is what we expect to find around here. It's rare that we would find one in that plumage around here. Their cousin, the ear grebe, is much more common in this area. So these guys are really showing up as a vagrant. Expected along the coast, not inland too much. These guys breeding western Canada and into Alaska. Again, these guys make floating nests. All the grebes make floating nests out of lakes. Another way to avoid predators with their nests. Next slide here. You see that the juveniles will actually hop on the parents' backs after they're patched, and the parents can even dive underwater with these guys on their back. Another hawk to the area is our red-shouldered hawk. And it's a bit different than the two hawks I showed before were what we call buteos. There are soaring hawks. And these guys really fall into that category of a soaring hawk, but they act a bit more like a forest hawk. So they're not so much out in the open like the other hawks. They don't need meadows as much. They hang out in trees a lot more. Kind of an open forest is more their preferred habitat. But they've got this nice red breast on them, black and white markings throughout the wings, and they also have a black and white tail that helps to identify these guys. If we look at the range map here, you can see they cover a large portion of the east coast and just a little bit on the west coast. And there's actually 5 subspecies of the red-shouldered hawk. And we have one subspecies over here in the west, which is actually separated by 1,000 miles by the next closest subspecies of the same family, of the same bird. And you can see they're not expected in Tahoe. So these guys, let's say that they're strays to the basin. It's one of those things where they haven't been showing up historically very much, but the last few years they started to come more and more to the basin. And Steller's jays are actually known for imitating hawks. Imitating a red-tailed hawk is something they're known for. But Dr. Will Richardson has actually heard red-tailed hawks imitating red-shouldered hawks up here in the basin, which means there's enough of them around that they think it's worth imitating them.
You mean the jays are imitating?
The Steller's jays are imitating red-shouldered hawks. And another one that spends its winter in the Central Valley of California are sandhill cranes. Just cool, big, lanky birds. And these guys occasionally will show up in the basin in the winter. They occasionally show up in the valleys surrounding the area, but you can see a lot of the range maps don't even show them coming up here very often. So, but these are a large bird, and with large birds, most of our small songbirds take 1 year to reach sexual maturity, maybe 2. These guys actually could take up to 7 years for them to reach sexual maturity. And they live to about 20 years if they make it that long. And also something that's a little unique about them is that they will actually migrate down from the tundra and the boreal forests with their young down to their wintering grounds. So you see these guys hanging out in big flocks, whereas ducks, other things that are shorebirds and things that are nesting up in the tundra and the boreal forest, don't tend to take off before the juveniles, and they just take off at the same time, but don't necessarily hang out together. And with that, I'll take any questions.
Is there a problem with the sapsuckers and the woodpeckers on cedar homes doing any real damage?
There is a possibility with that. Woodpeckers will pound on the side of your house for 3 reasons. One is if you have something that resonates really loud, because woodpeckers don't sing songs. So they look for something that makes a lot of noise that can do the noise for them. So that shouldn't cause any damage. If they decide to make a nest in the side of your house, they'll put a hole in there. But the third is if they think there's a food source in your house, they can really start making a lot of holes around there. There's a bunch of different theories on what's the best way to keep them away from your house. I had some woodpeckers creating holes in my house, and I put up some streamers that are kind of like glitter. And it seems to have stopped them, but so they can do some damage to your house.
There's lots of birds in that cover that do frequent this area. But I'm sure that that wasn't an oversight, simply because it's probably a lot more than we could have discussed.
I have the list of 300 that I can go through. There's only so much I can cram in at one time. But yeah, there's a lot of birds that we don't like. Even summertime visitors, like we've had scissor-tailed flycatcher in the basin in July. That's a bird you only expect to find in the southeast. So, birds end up in random places.
So we see tons of the Clark's nutcrackers this time of year. Do those leave in the summer? Do they come somewhere? Or
Usually not. Usually the Clark's nutcrackers are kind of wintertime. They move them down lower to the basin searching for food and things. There's not as much snow, so they can still find pine nuts and things. In the summertime, they're collecting all the pine nuts up from the white bark pines, caching them, and things like that. So they're higher up in the basin. But Clark's nutcrackers are known to also be eruptive, as seed crops of pine trees can also be patchy. And some years there's a lot, and then maybe one year there's just none for some reason. And so then Clark's nutcrackers can move to other parts of the Sierra or the interior west.
Are the pine siskins eruptive? It seemed to me like there were tons of them around last spring, and I hadn't noticed that before.
Yeah, pine siskins fall into the finch group, which also has the evening grosbeaks in it, the red crossbills in it, and those are also can be eruptive. So again, they're eating seeds, thistle, things like that. So those species all have eruptive patterns. And they can be hard to find some years, and not a problem yet. Like last, I think in August, I had a flock of like 45 pine siskins cruising around up at Mount Everest.
Another question, I've seen white pelicans this winter and last winter and had never seen them before. Have there been other people seeing more sightings of those, or was I just missing them before?
White pelicans, we actually had a white pelican on the Christmas bird count, which was the first time that showed up. They nest up at Pyramid Lake, and they'll actually travel, it's like 120, maybe 200 miles in one day searching for food. So they're actually spread out a wide area looking for food. So in the fall and early spring, it's common to see them, not in the winter, but they randomly come over to the basin, but they don't come here too often. So not unexpected, but not out of the usual.
Talking about pelicans, I've seen them at least 3 different times circling to get out of the basin, because I guess the air is so thin that they don't get that much lift, and they just go round and round and round, and gradually go lower, not Rose Pass, towards the valley.
Yeah.
Big flocks of cyclones.
Yeah, and actually they'll utilize the same thing that raptors do in the thermals coming up off the ground, catching those heat waves rising so that they expend less energy in order to fly out of the air.
We see blue herons down in Reno on our pond. Do you have them up here?
Yes, but we don't have all that many wetlands, and so the South Lake Tahoe is where you tend to find great blue herons around the basin, and the wetlands are smaller than they used to be, so there's just not as much habitat for them. So shorebirds, water birds like that, just are less frequent in the basin because there's less habitat.
I also have a white bird, white plumage wader. What would that possibly be?
Could be a Grady gret. It looks similar to a heron in shape and all that. Could be a Grady gret or a snowy egret. So if you look at the color of the bill, if it's yellow bill, it could be a Grady gret. If it's a black bill, it could be a snowy egret.
What do the quail do?
Well, quail didn't used to be the California quail, and now they're here, and they're all over. They didn't used to be over in the Washoe Valley and Carson Valley. They're all over there now. So they use their feathers and hunker down. They're still cruising around. They can still find some food places. Yeah, picking up all the things that everybody dropped off of the perch. But there's mountain quail that are here year round, and those guys tend to be higher up in the summertime, and just not very numerous. So.
What do the water birds eat when there's snow on the ground and ice on the lake or a pond?
They eat fish from a lake that's not there.
They just go.
Yeah, if the lakes freeze over, they take off and go elsewhere. If there's access to it, they might try to get under the water, under the ice there to go fishing, or eat the vegetation at the bottom. So, but yeah, if it's frozen over, their food source is gone, so then they'll move on to other areas.
How common are pinnated woodpeckers in Tahoe?
I would say not very common. They're here year round, but like I know there's a nesting pair in Tahoe City, a nesting pair in Blackwood Canyon. There's also a nesting pair down in South Lake Tahoe. So they're around, but their territories are so much bigger compared to other woodpeckers that there's just not a lot of space for them.
Are pinnated woodpeckers the ones that take advantage of burned areas?
Well, woodpeckers in general will take advantage of burned areas, some more so than others, like black-backed woodpeckers have been heavily associated with burns. And really what it is that when trees burn, a lot of beetles are attracted to the area, so there's higher food sources in those burned areas for the woodpeckers to come take advantage of.
Up on Chickadee Ridge, we always talk about the chickadees up there, but the Forest Service always says they don't belong there. The question is, are they there because of tourists who feed them? Or they, I mean, I know they, you're talking about what the lodgepole, I think they can live off of some of the pine cones and stuff.
Yeah, chickadees have a very cool thing that they do in that there's a needle miner moth that lays its eggs in pine needles. And so the larvae will stay there actually for 2 winters. And the chickadees are good at finding them the second winter. And so they'll actually go in and they'll shatter that pine needle to get at the grubs that are in them. So that's one of their food sources in the winter, because they're primarily insect eaters, but they'll take advantage of pine nuts or berries and other things too. They should be up at Chickadee Ridge, or I think the Forest Service is trying to call it like Big Tahoe Lookout or something like that right now. The thinking behind it is that the Forest Service doesn't like people feeding wildlife, so they don't want people going up there and having that happen. It's kind of like, well, how much different is it than a bird feeder? So it comes down to what do you believe is the best thing to do. And, it's a challenge to feed mammals because there's a lot of diseases that go back and forth between us and mammals, other mammals. Birds, not a lot of things can go back and forth, so there's a lot less risk as far as exposure to us. So they should be up there. Are they in higher numbers than they would be otherwise? Probably. I was up there at National Winter Trails Day when it was 15 degrees as a high, and the chickadees were everywhere mobbing everybody. So they were trying to get just a few more calories that day.
Well, because there have been days that I've gone during the week, and there are very few. It's like, do they know we're gone or something?
They know when the weekend is?
Yeah.
Very smart.
So I just want to say, anecdotally, I had a class that went out censusing chickadee begging behavior, and it was very specific around the trail. So when we went off trail and stopped and listened, the chickadees weren't there. And as soon as we got close to the trail, even without food, the chickadees started begging. So they seem to know where people are. And what's that?
You guys are right on the money, 7 o'clock. So
that we have up here in Tahoe. It weighs the equivalent of 2 quarters. So this little tiny bird that survives up here in the winter, and we've had some pretty cold temperatures. Like I've heard the coldest I saw was -16. On most nights, these guys are just sitting out on the branch of a tree. Occasionally they might huddle up with some other individuals for warmth, but they're exposed to the elements all night long. So how do they do it? Well, the main thing they do is with feathers. Feathers are nature's best and lightest insulator. It's the reason we have down jackets, down sleeping bags, down pillows. It's the best insulator that nature has created. And feathers are actually made of keratin like our fingernail, the protein. But the one difference is when feathers are growing in, they actually have blood that's flowing in to help support the growth of the feather, whereas our fingernails are always dead, so we don't have that blood flowing to them. But once the feather's fully grown, the blood supply is cut off, and so then feathers can fall out in that fashion and not bleed. But it would bleed if it was pulled out while they're growing the feather. So let's see. And also, feathers can be double the skeletal weight of a bird, and most birds that's the case. And we do a lot of research, and that stuff helps to inform our outreach and our education, which I'll get into those a little bit more. But we have a long-term goal of running a world-class nature interpretive center like Tahoe. And this would be to talk about the wildlife, more of that connection, the terrestrial connection, because there's a lot of great organizations already doing water stuff like UC Davis Turk. But for education, we have K through 5 in-school science programs that are hands-on, teaching kids about bugs, bats, and birds. We also have field trips to nature areas. We're doing field trip groups to see our bird banding research these days now. And we also do summer camps, getting kids out looking for bugs and exploring the basin. In outreach, obviously we do talks like today. But we also do nature walks. We have a Lake Tahoe Bird Festival and different things like that. And some of the walks we do are on the wildflowers, birds. We have snowshoe treks, like we have a snowshoe trek coming up this Saturday in Page Meadows on winter wildlife survival. We also have one for families on the 23rd up at Tahoe Meadows on calling it Snow Detectives, learning how to track animals in winter. We have also done some stargazing and meteor shower moon, things like that. And we also do citizen science, which is a way to get the general public connected to research. So collecting data for scientific studies, and most of these studies are regional or national, so contributing to a large data set like the Christmas bird count that we do every year, Swainson's thrush, bald eagle count, things like that. But let's move into the talk. So in the Tahoe Basin, there's been over 300 species of birds confirmed in the basin. Now in any given year, it's probably more like 150, maybe 200, depending on how mild or harsh the winter is. But considering that there's just over 900 species in the United States, we see about a third of all bird species in North America right here in Tahoe. We have about 63 or so that are year-round residents, and those guys will stick around the basin if it's a mild winter. Like last winter, we didn't have a lot of snow, not too cold. This winter is a bit different. But so last winter, we might have things like American robins and things like that that stayed around the basin, whereas this year, with more snow, colder temperatures, they may have taken off, gone down to maybe the Carson Valley or maybe the Central Valley of California. So the question is, how can our birds survive? If we take this mountain chickadee here,
tonight we have Kirk Hardy from the Tahoe Institute of Natural Science. Science. Okay, thank you. For natural science. And Kirk studied at UNR and is also an adjunct professor here at Sierra Nevada College and will be talking to us about winter birds. So I'll turn it over to you.
all right.
Thanks. Give him a warm round here.
Well, thanks everyone for coming out tonight. I'm hoping my voice makes it through, as my wife and son got sick on Sunday, and now today is my turn. But anyways, I'm one of the co-founders and co-executive directors of the Tahoe Institute for Natural Science, and we're talking about winter birds of the region tonight. But first, before we get into that, just a little bit of background on the organization I work for. We really have three main outreach areas, or three main areas that we work with. The main one being our research, which we do a lot of wildlife research in the basin, birds, insects. We've done some tiger beetle studies. We're also doing some snowshoe hare and white-tailed jackrabbit studies right now. So also coming into winter, when birds molt, they can actually add up to 50% more feathers. So they can really add on a lot more feathers in there. And our small mountain chickadee there can have roughly 200 or 2,000 feathers on it. When we get to a bird like a tundra swan, they might have like 25,000 feathers. So a lot of feathers in these birds. So now we'll cover some types of feathers. Of course, imagine everybody's heard of flight feathers. And if we look out here, these feathers out here are called the primaries. This is what produces the thrust, the force to push the birds forward. And then over here, we have what's the secondaries, and that's what produces the lift to the bird. But if you look, you see that they're asymmetrical in shape. They have a smaller leading edge with a longer trailing edge, just like the wing of an airplane. So it functions the same way an airplane wing being made after bird feather. Another type of feather we have are contour feathers. And I couldn't find a good picture that represented this. So these are symmetrical. They have the same amount of feathering on both sides of the shaft.